Hi, we're going to be looking at how to calculate two statistics. The first one we're going to look at is sample variance, and the second one is sample standard deviation. Both of these statistics are measures of spread. So if you're using a measure of center, like median, then the measures of spread you might use are range and interquartile range. You might also talk about the quartiles or even the percentiles. But if you're using the mean as your measure of center, then it makes sense to use variance and standard deviation as your measures of spread or variability. Now we're going to be looking specifically at how to do this for sample data. If your data actually represents an entire population, if it comes from a census, then you would use a slightly different formula for this. And hopefully you've got that formula, or if you don't have it, you can look it up. So the first thing we need, of course, is some sample data. Now, I have made up some data. I tried to choose some data that was relatively nice to look at, but completely unrealistic. And here's what I mean by unrealistic. First of all, there's only 4 data values. Now, I would pretty much never talk about the spread or the distribution shape of something that only has 4 data values, because there's not enough there to really see what's going on. But there's enough there to see how this formula works, and that's our goal here. So we're just going to go over the mechanics of how to calculate this. And it turns out there's 2 ways to calculate this. 2 separate formulas. One of the formulas says that s squared equals the sum of the x sub I minus x bar squared over n minus 1. And this, of course, goes from I equals 1 to n, where n is the sample size. And in this case, the sample size is 4, because I have 4 data values. Now, I like this formula because this formula is easy to remember if you understand the idea of standard deviation. xi minus x bar, that's the deviation, how much xi deviates from x bar. You square that, you divide by n minus 1. So that's nice, easy to remember formula. On the other hand, some people prefer to use s squared equals the sum of each x sub I squared minus the sum of each x sub I squared over n, and all of that goes over n minus 1. The second formula, people tend to prefer using that one if they're doing the calculations by hand. I say by hand, but I'm going to be using a calculator as well. So let's start with the first formula, and we'll calculate these things. You'll notice for the first formula, we need to find x bar. So the first thing to do is to find x bar, and that, of course, is 3 plus 6 plus 11 plus 4 divided by, which equals 3 plus 6 is 9, plus 11 is 20, 24 over 4. And 24 over 4 is, of course, 6. So the mean is 6. Now you'll notice I didn't have to put the data in order. 3, 6, 11, 4 seems to be out of order. But that's okay because we're using the mean and not the median. If we'd been finding the median, you'd need to put that data in order first. Now that we have the mean, we're ready to actually calculate this. So here we go. S squared equals the first value minus 6 squared plus the second value minus 6 squared plus the third value minus 6 squared plus the fourth value minus 6 squared, all over n minus 1. And so we have negative 3 squared plus 0 squared plus 5 squared plus negative 2 squared over 3. Now when I square these, remember if you square a negative number, it's going to be positive. So don't bother with the negative sign. I know that negative 3 squared is just 3 squared. And if you're using a calculator, I recommend don't type the negatives. Just go 3 squared is 9 plus 0 plus 25 plus 4 over 3. And so we're getting a final answer then of 9 plus 25 plus 4, 38 thirds. And if you prefer, you could write that as 12 2/3, or you could write it as a decimal, 12.6 repeating decimal. Okay, so that's the sample variance calculated by the first method. Now, if we chose to use the second method instead, we would not need to find the mean. However, what we would need to find, first we would need to find the sum of the x sub i's. So we're going to take each data value and square it. 3 squared plus 6 squared plus 11 squared plus 4 squared. That's 9 plus 36 plus 121 plus 16. And I get 182. And then we would also need to find the sum of the x sub i's squared. That is, we add them all up before squaring. So that would be 3 plus 6 plus 11 plus 4 squared. And that's 24 squared. And according to my calculator, that's 576. So now we're ready to actually calculate this thing. And as we do that actual calculation, we get that s squared equals 182 minus 576 over n. N is still 4. All of that goes over 4 minus 1. So it's 182 minus 576 divided by 4, that's minus 144 over 3. And again, we get that this is 38 thirds, or 12 and 2/3, or 12.6. So again, it's completely up to you which one of these methods you want to use for calculating the variance. But that's what we've calculated. Right now, we have just found the sample variance. So what if we wanted to find the sample standard deviation? Well, that's easy, and it doesn't matter which method you use to begin with. To find the sample standard deviation, keep in mind what the symbol says. The symbol for sample standard deviation is just s, but variance was s squared. So what that tells me is I just need to take the square root of s squared. And that means the sample standard deviation is the square root of 38 thirds. Or if you would like to approximate that, you can use a calculator to approximate that. And when you do so, you should get 3.559. Now, I strongly recommend that if you are following along at home, that you go ahead and use your own calculator to calculate that. Make sure you know how to properly input square roots and fractions and that sort of thing into your calculator. Well, that's it for now. I'll see you next time.